So for those of you who don't know me, my name's Dave Stokes. I organized the MySQL track for scale. This year's been a little bit different since we moved back to Pasadena from the little thing we had last summer back at the LAX Hilton. And today I'm talking about storing JSON and relational databases. A little bit of background. This is the description from the schedule. Mainly relational databases are known for being very strict on data types and preset schemas and very rigid. Has a lot of things going for it, including structured query language. And this talk's going to talk about what do you do with something freeform like JSON in a strict relational database. JSON has a lot of interesting properties to it that makes it attractive for using in a relational database. But there's a lot of purists out there who'd hate it. But we're going to go over what it benefits for you. About me, for about a year, I've been a technology evangelist at Percona. Before that, I was a community manager for Oracle MySQL. I've been using MySQL since it came out. I wrote a book on using MySQL with JSON. That the second edition is now available on Amazon. And for those wondering, yes, that is an $11,000 guitar that I got to play for about 15 minutes before the wife told me no. Differences, SQL versus no SQL. There's a lot. About 10, 12 years ago, we were all hearing that SQL databases were dead. Everyone's going no SQL. Don't worry about learning structured query language. They're going to die off. Well, the great thing about traditional databases is that despite the rigidity of using normalized data, it does structure a lot of logical information the way businesses and other organizations use it. And putting things in a normal form helps you organize and use that data, and it actually saves space and processing power. The other great thing about it is that it enforces rigor on your data. You'll see a little bit of that demonstrated later. If you try to put a string in a numerical field, it's going to complain about it. If you put a numerical value into a string field, that's acceptable. But it does try to watch out to make sure you're not putting bad data in your database. Unfortunately, you have to decide how you're going to format your data up front. For a lot of projects, especially in the agile developer world, they work incrementally, and they're not used to doing that. So asking them to plan what they're going to have for tomorrow's dinner today when they're hungry at lunchtime doesn't often work out. So NoSQL JSON databases, there's a lot of types of different NoSQL databases, but the one we're talking about today are the ones that are basically JSON document stores. Free form and flexible, you can change things on the fly as often as you want. Data stored in key value pairs. Whatever you want to put in there, you can put in there up to the maximum size of the bucket. You can have different formats in the same schema, and your data decisions happen on output. So until you go to use the data, you really don't have to worry about it, they say. Okay, quick time quiz. We're going to create a table called Q1, 2 columns. One's called question 1, an integer. Another one called question 2, that's a car 5. Now, the first insert statement you see there, I'm trying to insert the value of 1 for the question 1, which is an integer, and the string Southern California Linux Expo 20X into question 2. As you can see here, the first error message you see is data too long for column question 2 at row 1. It's a car 5, we're trying to put in something much bigger. The database protects you from doing bad things. Now the second one, insert into Q1 the value LOO, which looks kind of like 100, and the value scale. And you see data truncated for column question 1. Okay, now comes the quiz. What actually ends up in table Q1 after you run this? Any guesses? Nothing. If you don't know Dr. Phil here, he's not the one from TV, but he should be. Well, this is past. Okay. Here's the same thing in Postgres. How many Postgres fans do we have in here? Okay, this is a little bit of education for the MySQL folks. Once again, we create a table called Q1 with the same format. We try to put in the same value, and notice that on the second one, we still get the value too long for the car 5. Second insert, where we put in the numeric value of 5 and the string scale. So what ends up in the Postgres version of Q1? What you expect. So about 10 years ago, as I mentioned, the NoSQL vendors claimed JSON solved a lot of problems with relational databases. Goodbye, relational databases. People don't like writing structured query language, which is ironically the number 2 language from the IEEE members. They announced that we are going to support relational features like transactions. A couple of the NoSQL databases made good efforts at this and got limited good results. And relational databases are still around, so they didn't quite get rid of those. Now, ironically, all the relational databases added JSON support. So, what is JSON? Well, according to Wikipedia and everyone else, it's JavaScript object notation. And it's an open standard format, has very little rules on it. We'll talk about some of this a little bit. It's become the most popular data interchange format, and it is used just about everywhere. Now, the difference is in its use is that developers tend to think of data on the left, where you have that thing in the curly braces, where you have the key of ID and the value of 1, 2, 3, 4, 5. Or on the right-hand side, the relational model is you create a table and you define what the data looks like and then put the data in there. So the relational model. If you don't know who this is, he wrote a seminal paper for IBM on something called structured query language. IBM immediately tried to kill it off. There's some odd machinations and weird twists of history. Some guy named Larry Ellison formed a company called Oracle and was able to exploit SQL, and we've been off on the races ever since. IBM eventually released some SQL. So structured query language, what makes it so special? It's the only programming language from the 1970s that's still heavily used. I know one of these days someone's going to tell me, yeah, I'm still using Prolog. Yeah, or Smalltalk. It introduced the concept of accessing many records from a single command. Before this, you made one request, you got one record. You made another request, you either got another record or an end of table, end of file, end of something marker. Data divvied up into logical groupings. You have customer data, you have product data, you have order data. For your customers, you'll have the table name normalized into first name, last name, address, phone number, credit information, all that. And originally it was designed to minimize data duplication. Disk drives were very slow, very large, and very expensive. And this was particularly useful in handling structured tables, data incorporating relations among various entities. So if you're trying to get your sales information, all your sales information is one place, you can run all your analytics against that. Now, a quick word about object relational mappers. I don't know if there's any fans of ORMs in there, but my one word I always use when I'm talking about ORMs is to avoid them. Why? Well, it's easier to write good SQL than it is to suffer the problems that happen with ORMs. They make assumptions, they write bad queries, and they do stuff that generally mess you up. It's a lot easier to just write good SQL. By the way, the overhead, extra layer of complexity. I don't know if you looked at your stack lately from the OS up. Everyone seems to be running extremely heavily layered applications that just make me boggle that they can get away with that. Other things that ORMs do is they do not do things with sets. They want to do multiple round trips. They'll take full advantage of the database, and they do not usually manage concurrency control very well. And if you're trying to do something with a batch or bulk, it may not work right. So generally, I'd say to avoid them. So why didn't JSON document databases replace relational systems all across the board? Well, as I mentioned, they tried. There's still some good uses for them, but there's so much that you can do with a relational database that make it a very powerful tool. So Another quiz this time in Postgres. We're going to create a table called Q2, and this is going to have a column of JSON-B format. Postgres doesn't have one JSON data type. In typical Postgres fashion, they have two. And in this case, we're going to insert into Q2 this JSON string, where you see we have a key value of an uppercase A and a value of 1, an uppercase A as a key and a value of lowercase a, and uppercase A with a value of 1, 2 in an array. What gets into the database? Any guesses? The last one. So you have to be careful. JSON's free form, but JSON-B and MySQL act very similarly. Matter of fact, let's do the MySQL version of that. And surprise, surprise, it ends up with the same answer. So the last one wins. Now, JSON, as I said, is free form. You can do pretty much whatever you want to do as long as it's in UTF-8 MB4. You don't have to change your tables to put in new data. You just put in another key value. You're dealing in documents, not rows. Unfortunately, things get easily duplicated. If you have outdated data out there, you may not be replacing it when you do an update. Many-to-many relationships are nearly impossible to do. People will nest objects to absurd limits that make it almost impossible to parse. Consistency is not a strong point. Top of the right-hand column, you'll see people do things like this. They're recording email. I write it as email, all lowercase. He camel cases it. He mixed cases it. He does all uppercase. She does all lowercase. Someone spells out electronic mail, and it just gets messy because there's no way to enforce rigor in most cases. So, two different approaches to using JSON in a relational database. Now, MySQL and Postgres are the ones I'm talking about today. Other databases have JSON data types, but MySQL added a JSON data type 8 years ago. It's stored in a binary blob, and you have roughly a 1 gigabyte payload. And it is sorted by key. JSON-B, which was added to Postgres back in 2014, is kind of the same idea, but its payload is 16 megabytes. And the regular JSON support in 9.2 was back from 2012, has a 1 gigabyte payload. Pay attention to that if you do large JSON documents. Most people don't come anywhere near that, but it is possible. And a confession, you could store JSON documents in a database before the JSON data type. You put it in a big text field. Now this became almost impossible to search. I ended up doing nasty things with regex. If you had to change one item, you had to write out the entire document again, which was very expensive. And it just wasn't easy to use. Now here's a MySQL JSON example. We're going to create a table called ATO, where we have a primary key called int, and we have a data column called JSON. And if I insert data in there with the JSON document with a key value of name and Dave and answer in 42, and I do a select, a general select without using any of the JSON functions, I get the data back looking like this. Postgres is very similar, and JSON-B is very similar. So why does Postgres have JSON-B? Well, the data is stored as exact copy of the input text. So sometimes if you need item potency, this is the way to do it. By the way, the first edition of my book, the text editor, or the guy who's reviewing my text, changed the word from item potent to impotent. Not exactly a great thing to find out when your book goes to print. So JSON-B stores the data in a decomposed binary form. It's very efficient, it's very fast to process, and it supports indexing. Okay, using the JSON tools from within MySQL, you see that we have the double arrow pointer. There's a single arrow pointer and a double arrow pointer that goes out, and it says, okay, from the column named data, anything that's on the root path with the key of answer, give me the value from that key value pair. Postgres is very similar for the JSON and the JSON-B. Now, one thing to note is that with MySQL, if you're doing the single arrow, it sends it back in quotes. If you do the double arrow, it strips the quotes for you. Postgres does the same thing pretty much, exactly the same thing. So JSON functions. This is where it gets real interesting, because in the past where you store everything as a big text string, when you needed to edit it or change it, you had to rewrite the entire thing back out to disk. With the JSON functions, you can basically get whatever you want and just write what you need to change. Now, both databases, their path expression are based on XPath. There's lots of operators. Postgres has a lot of interesting regex filters that are very handy. And if you're using one and switch to the other language, they're just slightly different enough where you will basically be referring to the manual on a constant basis. Now here's a list of MySQL's JSON functions. The crazy thing is Postgres has even more, and they have more coming. So indexing. JSON, being a blob, can't be directly indexed because you don't want to index the entire blog. If you have a gigabyte of data, you don't want to have huge indexes with each index row being a gigabyte. So in this example, we're going to go out and we're going to select from a column called data, get the name, and as you see, it comes back with the data. But if we run explain on this, and if you're not used to explain, it's how you debug queries or try to optimize them. And we say, okay, we want to select this and put a prepend explain in front of this query. It comes back and tells us that the cost is 25.88 and it has to read 1,270 rows. Basically, it's a full table scan, which if you're not a DBA, full table scans are not performant. You don't want them. Now, if we create an index on that data and we run explain, you notice that the cost goes from 25.88 to 1.01 and reads exactly one row of data. A lot faster, a lot more efficient. Now, MySQL, you can do a similar thing. One of the other options you have is that you can use a generated column, where you basically say, in this case, we're going to add a column called H, where we're going to take any data that starts with name on the main path, and we're going to put that in its own column, materialize its own column called H. So you've taken the stuff out of JSON and permanently put it in its own column. And if we do an index on that, you can see that the cost goes down to, well, the cost is 0.35 and only has to read one row. JSON-B is a little bit more difficult in the Postgres world to index, but it's not that much more difficult. The advantage in the JSON world, the Postgres world, is that you have a whole bunch of options for the indexes, gin, btree, a whole bunch of others. Now, something that MySQL has that I thought was an amazing invention was that previously, until this came along, you had one entry in your data, one entry in the index, one-to-one relationship. With multi-value indexes, when you could actually have multiple values indexed within a row. So if you had an array, in this example we have arrays of numbers here, you can actually index each one of those and search for them individually. So that one-to-one limit is no longer there. So when you do use the multi-value search, you use the keyword member of, and you're basically saying anytime there's a 7 that's a member of this field, come back and give me the results. Now, as I mentioned earlier, Postgres has an embarrassingly rich amount of indexes, and MySQL, you're used to btree, and that's about it. With Postgres, you can basically use gin indexes to write your own indexing function. Now, this is something that I found is very interesting. I mentioned generated columns, where you materialize a column from the JSON data into its own column, so you permanently have that data. JSON table takes your unstructured data and temporarily turns it into a structured table for processing with SQL commands, whether it be window functions, aggregates, or in this case, we're just doing a where clause where we're looking for a value greater than 1992. Now, this works really neat. There are ways to do things when you have missing values. You can add default values. There's a whole bunch of other interesting stuff you can do with this. And now you can use the JSON just like any other table, and the table is only in SQL format for a short amount of time. The big trouble with this is it did not make it into Postgres 15. So if you're running the latest and greatest, you can't do this with Postgres. MySQL's had it for a couple years. Hopefully it'll make it into Postgres 16, but right now you can't do this with Postgres. As I mentioned, there are ways with JSON table to tell it, give default values if there's no value. If there's an error, you can specify a value or make it use the default value. Or if it's empty, you can specify a value. So it's very handy if you're doing analytics on data and you have missing values. Now, this is something else that MySQL alone has had for a couple years. It puts the work of the folks at JSON-schema.org ideas into use. Now, JSON by itself has no way to check data types, ranges, required values by itself. But the folks at JSON-schema.org came up with an idea where they have a template. In this example here, we're going to set our template up as we're going to take an object. The name of that object is going to be called my age. It's going to be a numeric type. It's going to have a minimum value of 28, a maximum value of 99, and then you have your data. And when you run that data through, it comes back and says, yes, it does fit that template. It's good to put in. Or 0, it doesn't match the template, don't let it into your database. Keeping bad data out of your database is important because it's easier to keep bad stuff out than to have to go back and correct it later. So, whoops. I'm sorry, I don't have an example in here of using this with a check constraint. You can actually use required fields with this, so if you need something to be in there, like that email field, you can have that required. I thought I had a slide on that, I apologize. Okay. Duality, this is something that's coming out. Other people and other databases are talking about it. This is something that Oracle added in Oracle 23. Big Oracle heads I know are excited about this. I'm not quite sure why. What happens is you create a view using GraphQL on top of your JSON, on your relational data, and it returns JSON. Now, if you're in a big Oracle shop and this makes sense to you, please let me know. I'm still scratching my head over this. Okay, recommendations, and this is directly from the Postgres manual. JSON is a lot more flexible than the traditional relational model. If you're in a shop where they're demanding changes to your schema and you have big tables, this might be your savior. You're able to do things on the fly with the JSON data and then later alter your table to inculcate the new stuff. And you can use both approaches, the traditional and the JSON side by side. It just takes a little extra effort on your part. If you need multiple flexibility, use the JSON as much as you feel comfortable with. Now, if you want speed and you want to make sure that rigor is enforced, use the traditional columns. Use the techniques I showed you earlier to pull this stuff out of JSON if you really need that. Now, JSON data generally is subject to the same concurrency control, so if you have a lot of people trying to enter the same record and modify that, you have to be aware of that. Be careful when you're storing large documents because, as I mentioned, you might overflow, and that causes its own different set of problems. You usually get just an error that it won't write it. Also, limit the amount of layers you do when you embed your data. You can make it so that you can't parse it. And like the last one, JSON documents should each represent an atomic datum that business rules dictate cannot reasonably be further subdivided into smaller datums. Try to keep to the relational model as much as possible. Why? Because we know it works. It's been around since the 70s. So with that, I'm going to wrap up and let you all head off into the rain a little bit early. Once again, for speed, use relational columns. Plan your schemas by how you want to use the data. I can't tell you how many times in the past year I went to DevOps days all around the country and I was talking to developers and they're saying we're having trouble with our databases. Well, what's your main problem? Well, we design them this way, but we use them another way. Well, don't do that. Once again, JSON table is a great way to temporarily make unstructured data structured. Use generated columns to materialize JSON data into their own columns when you need to use it that way. Do not use JSON as a junk drawer or an excuse. It also helps if you keep your facts in one table and your derived information in another table. And once again, don't overly embed data in your JSON document. The more complex the path, the more error-prone it becomes. Very interesting read here, even if you're a MySQL person. The JSON folks have a lot of good insight into using it because they've been using it a little bit longer than MySQL. By the way, you're all invited to Percona Live, which is May 22nd to 24th at the Denver Marriott. We will be talking MySQL, Mongo, Postgres, MariaDB, maybe some other things like FerretDB, Orchestrator, Proxy SQL, and a whole bunch of other stuff. And with that, do we have any questions, comments, or concerns? By the way, if you want these slides, it's speakerdeck.com/Stoker. Yes, sir. Is there a what? Unfortunately, there's a fee for Percona Live. We can't do it all for free. I mean, we do so much open source. By the way, if you've never tried Percona's variations of software like MySQL or Mongo, we give you enterprise features for free. So the stuff that MySQL charges you for an enterprise license or Mongo charges you for an enterprise license, at-rest encryption, data masking, connection poolers, we give it away. So just a little bit of feed isn't that bad. Well, I recognize a lot of familiar faces here. Thank you for coming back. If this is your first open source show, you picked a good one. Sorry about the weather. And with that, thank you all for coming out and have a good show. Thank you.